Making sure that everything is running as it should. See here. Coming through, coming through. Go, where are we at? Should be coming through now. Yesterday, Stream Manager. There we go. Now it's in. Good, good. So that's ready to go. And this one needs to be signed into. Hello, hello, everybody. Today's the second stream. Second stream of today, second study stream. And currently, it is August 21st. August 21st, 2026. Just signing in here. There we go. Okay, so as I said, August 21st, 2026, it's currently 3:45 in the afternoon. I was planning on being back right around 3 o'clock, but had some stuff come up. So anyway, but back at it, and we're going to do 2 hours, a 2-hour session now. The purpose of the stream is to do some review of mathematics, but it's primarily the purpose is to continue to study and to develop capability in the area of Gregg Shorthand. I'm gradually getting faster and more fluent in the system, but it still needs a little bit more work. So I wanted to double down on that a little bit more, and that way, when maybe in about a week or two, hopefully, when I'm beginning to stream more academic material, then I'm able to actually use Gregg Shorthand in a more coherent way and not be quite so timid with the system. So with that, we're going to get started. If you're interested in any sort of links that are down below in the video, go take a look at them. There's a link to the PDF that I'm using. There's a link to the website that I use, Zernal, all that good stuff. So anyway, without further ado, let's go ahead and get into it, shall we? Currently on page number 60. I think I'm on 65. No, page 66, I think. Let me pull it up here and take a look. Let's minimize the screen here. Test, good. So we're on 130 actually. If we reject, and page 68. So we're looking at article 130, okay? What I'm going to do is I'm going to zoom out and I'm going to read through all of article 130 first, and then we go on to 131, okay? Here we go. Pen. Good, everything's lined up as it should be. Here we go, Article 130. The reason for the recurrence of the figure in the same, of the figures in the same order, is as follows. If 1000 be divided by the number 247, the remainder at each step is less than 247, being 0, or one of the first 246 numbers. If then the remainder never become nothing, by carrying the division far enough, one remainder will occur. Let me check occur. Is that the one where we have to do the UR? Nope, that's correct. That is correct. Good. Will occur. A second will occur a second time. If possible, let the first 246 remainders be all different. That is, let them be 1, 2, 3, etc. Up to 246. Variously distributed. Variously distributed. So we need a disjointed D below for distributed. Okay. As the 247th remainder cannot be so great as 247, it must be one of those, or one of these, which have preceded from the step where the remainder becomes the same as a former remainder. It is convenient. No, it is eventual. It is evident. Evidence. Let me check evident. It is evident that the former figures of the coefficient must be repeated in the same order. There we go. Moving on, 131. You will here naturally ask, let's add a line below. Naturally. I think that's naturally. Let me go ahead and check. Nope, that's right. Naturally just requires the R. Here we go. You will naturally ask, what is the use of decimal fractions if the greater number of fractions cannot be reduced at all to decimals? What is The answer is this. The addition, subtraction, multiplication, and division of decimal fractions are much easier. Than those of than those of common fractions. And though we cannot reduce all common fractions to decimals, yet we can find decimal fractions so near to each of them that the error arising from using the decimal instead of the common fraction will not be perceptible. For example, if we suppose an inch to be divided, into 10 million of equal parts. One of those parts by itself will not be visible to the eye. Therefore, in finding a length, an error of a 10 millionth part of an inch is of no consequence. Even where the finest measurement is necessary. Now, by carrying on the table in Article 129, we shall see that 1428571 over 1 million does not differ from 1 over 7, by 1/millionth. And if these fractions represented parts of an inch, the first might be used for the second. Since the difference is not perceptible. In applying arithmetic to practice, nothing can be measured so accurately as to be represented in numbers. Without any error whatever. Whether it be length, weight, or any other species of magnitude. It is therefore unnecessary to use any other than decimal fractions since by means of them any quantity may be represented without much correctness. As by any other method. We have some examples, but we'll skip that for now. Go back up and we'll read Article 131. You will here naturally ask, what is the use of decimal fractions if the greater number of fractions cannot be reduced at all to decimals? The answer is this. The addition, subtraction, multiplication, and division of decimal fractions are much easier than those of common fractions. And though we cannot reduce all common fractions to decimals, yet we can find decimal fractions so near to each of them that the error arises from using the decimal instead of the common fraction will not be perceptible. For example, if we suppose an inch to be divided into 10 million of equal parts, one of those parts by itself will not be visible to the eye. Therefore, in finding a length, an error of 10 millionths an error of 10 millionth parts of an inch is of no consequence, even where the finest measurement is necessary. Now, by carrying on the table, by carrying on the table in Article 129, we shall see that 1428571 over 1 million does not differ from 1/7 by 1 millionth. And if these fractions represented parts of an inch, the first might be used for the second, since the difference is not perceptible. In applying arithmetic to practice, nothing can be measured so accurately as to be represented in numbers without any error whatever. Whether it be length, weight, length, weight, or any other species of magnitude. It is therefore unnecessary to use any other than decimal fractions, since by means of them any quantity may be represented with as much correctness as by any other method. Good. Next, Article 132. Every decimal may be immediately reduced to a quantity consisting either of a whole number and more simple decimals, or of more simple decimals alone. Leaving one figure only in each of the numerators, or having one figure only in each of the numerators. Take, for example, 147,326 over 1,000. If we reduce this, we get 147 over 326 over 1,000. Let me just add another page here. And since 326 is made up of 300, 20, and 6, by 112, (326 over 1,000) is equal to 300 over 1,000 plus 20 over 1,000 plus 6 over 1,000. But by 108, (300 over 1,000) is 3 over 10. And 20 over 1,000 is 2 over 100. Therefore, $147,326 over 1,000 is made up of 320 and 6. Hold on. Nope. Is made up of 147 plus 3 over 10 plus 2 over 100 plus 6 over 1,000. Now, taking any number, for example, 147,326, and form a number of fractions having for their numerators this number. And for their denominators, one, 10, 100, 1,000, 10,000, etc. And reduce these fractions into numbers. And more simple decimals. In the foregoing manner, which will give the table below. And that is a decomposition of a decimal fraction, showing how you can take all of your fractional elements and make them into smaller and smaller examples, and then you reduce the following fraction into a series of numbers and more simple fractions. So that's just the matter of writing this out. Decomposition of fractions, okay? I'm gonna skip all those exercises for now. Once again, when we actually get into the mathematics side of the house, not just the shorthand, then I will definitely be writing out those examples because that's all really beneficial stuff to study. So, but for now, I don't need to worry about it. It's just a matter of keep on plugging away. So let's keep going. We go to Article 133. Next article, but before we do that, I need to go ahead and read through Article 132. Here we go. Every decimal may be immediately reduced to a quantity consisting either of a whole number and more simple decimals, or of more simple decimals. Of more simple decimals alone. More simple decimals alone. Put a little dot there. Having only one, let's fix the one. Having only one figure in each of the numerators. Take, for example, 147,326 over 1,000 as 147 times 3, or 147 and 326 over 1,000. And since 326 is made up of 300, 200, and 6, by Article 112, 326 over 1,000 is equal to 300 over 1,000 plus 20 over 1,000 plus, going on, plus 6 over 1,000 by Article 108. 300 over 1,000 is 3/10, and 20 over 1,000 is 2 over 1,000. Therefore, 147,326 over 1,000 is, if we're going to do decomposition of the fraction, is made up of 147 plus 3 over 10 plus 2 over 100 plus 6 over 1,000. Now, take any number, for example, 147,326, and from a number of number of fractions having as the numerator this number, and for the denominator, 1, 10, 100, 1000, 10,000, etc., and reduce these fractions into numbers and more simple decimals in the foregoing manner, which will give the table below. And the table below is what he laid out right here. So I'm going to go ahead and make a note of that the for further examples, read the textbook. For full, oh, what is full? Yep, curves down other direction. For full example, consult the textbook. There we go. For full example, consult the textbook. And that also includes the exercises, because I'm going to skip past all those and go straight into the next portion. Okay, Article 133. If in this table and others made in the same manner, you look at those fractions which contain a whole number you will see that they may be made thus. Mark off from the right hand of the numerator as many figures as there are ciphers. In the denominator by a point. or any other convenient mark. This will give, so essentially he's talking about the decimal point, right? Fractions of and then of course these examples here. So this will give 14732.6 when the fraction is all over at the 10th, 147.26 when we have 147,236 over 100, that value over 1000, etc. The figures on the left, so any other convenient marks. So once again, I'm just going to make a note here and say see textbook. And once again, if I wasn't writing backwards, I'm sure I would just do the values, but the writing backwards is just a little bit too strange to do a lot of numbers. So unless I have to, I really don't choose to go that direction. See textbook, okay? The figures on the left of the point by themselves make the whole number. Which the fraction contains. Of this on its right, the first is the numerator of the fraction, whose denominator is 10. The second of that, whose denominator is 100. and so on. We now come to those fractions which do not contain a whole number. And that concludes 133. So let me go back and read over 133. And then continue to 134. There we are. If in this table and others made in the same manner, I'll hold on. I think that's what it was. That's look. You look. Yeah, you look. Okay. There we go. You look at those fractions which contain a whole number, you will see that they may be made thus. Mark off from the right hand of the numerator as many figures as there are ciphers in the denominator, and a point or any other convenient mark. Once again, see textbook. The figures on the left of the point by themselves make the whole number which the fraction contains. Of those on its right, the first is the numerator of the fraction, whose denominator is 10. The second of that whose denominator is 100, and so on. We now come to those fractions which do not contain a whole number. And that is now 134 is our next one. Okay. The first of these is 147,326 over 1 million. In which the number of ciphers in the denominator is the same as the number of figures in the numerator. If we still follow the same rule, and mark off all the figures, by placing the point before them, thus point 147326 the observation in let's see what observation is. Is it just OB shun? No, it requires observe shun. Observe shun. Still holds good. For on looking at, let's add another page below. And then we have this value 147326 all over 1000. In the table, we find it is we lay it out then 1/10 400ths 7,000ths 3/10,000ths 200,000ths and finally 6/millionths. the next fraction is 147,326. So essentially what they're speaking of is the idea of decimal. So the whole idea of a decimal number is derived from the decomposition of fractions. You think of it as the reverse of positionality. So you remember how at the beginning of the book we were talking way back when we were talking about how positionality determines the numbers as we go to the left of the page. As we go to the left of the page, our position goes up higher. In this instance, what De Morgan is speaking of is positionality, but positionality of increasingly smaller fractions as you move to the right of the page, okay? So next one here, the next fraction, as he's laying out, new paragraph here. Is, and then 147,326 all over, what is that? Oish, 10 million? All over 10 million. 1, 2, 3. There we go. All right, and which if we find by the table, which if we find by the table to be, we lay it out, we end up with 1 over 100, 4 over 1,000, 7 over 10,000, 3 over 100,000, 2 over 1 million, and finally 6 over 10 million. Two, 3, and there we go. All right. In this, 1 is not divided by 10, but by 100. Ah, but by, what is that? But by, is it just a BB, I think? Let's go check it. Yeah, BB would be the stroke for but by. Like so. I'm gonna add that. Okay. If, therefore, we put a point before the whole, the rule is not true. for the first figure on the left of the point. Has the denominator which? According to the rule, the second ought to have. Let's check ought to. What is ought? Yeah, so ought to. It's a fun one. Write it down. The second, that which the third ought to have, and so on. Let's see here. According to the rule, the second ought to have. The second, that which the third ought to have. How about that which, right? Would be that, correct? That's that which. Let's see if that's correct. I think it is. I think that is going to be that which. Or I'm getting into the phrasal mode now. That which. Good. I'll add that. That which the third ought to have. There's ought to be, ought to have. And so on. In order to keep the same rule for this case, we must contrive to make 1 the first, 1 the second figure. Contrive? I wonder if it's just contry. We must contrive to make 1 the second figure. on the right of the point instead of the first. This may be done by placing a cipher between them. Oh no, between it and the point. Thus, point 0.14732 Hence the rule holds good, for by that rule this fraction is, or here, the rule holds good. For by that rule this fraction is, and if we lay it out, 0/10, 1/100th, 4,000ths, 7/10,000ths, 300,000ths, 2/millionths. There we go, right? Yep. And finally, 6/10,000,000ths. All right, which is the same as the preceding line. Since 0/10 is 0. And need not be reckoned. Let me check reckoned. Oh, no, that was correct. There we go. Similarly, when there are two ciphers more in the denominator, when there are two ciphers more. When there are two ciphers more, in the denominator, then there are figures in the numerator. The rule will be true if we place two ciphers between that point. And the numerator. The rule, therefore, stated fully is this. To reduce a decimal fraction to a whole number, and more simple decimals, alone if it do not contain a whole number, mark off by a point as many figures from the numerator, as there are ciphers in the denominator. If the numerator have not places enough for this, Write as many ciphers before it as it wants places. And put the point before the ciphers. Then, if there be any figures before the point, let's go to add another page below. Elements of Arithmetic, section 6, page 8. Here we go. Before the ciphers, the point before these ciphers, is that right? If the numerator have not places enough for this, write as many ciphers before it as wants places, and put the point before these ciphers. Then, if there be any figures before the point, they make the whole number which the fraction contains. The first figure after the point with the denominator 10, the second with the denominator 100, and so on. Are the fractions of which the first fraction is composed. And that concludes 134. So I'm going to read back through. Before I do that, let me grab a little drink of water. It's a lot of material. There's 134. Okay. All right, let's begin. 134. The first of these is 14732, or 147,326 over 1 million, in which the number of ciphers in the denominator is the same as the number of figures in the numerator. If we still follow the same rule and mark off all the figures by placing the point before them all, thus 0.147326. The observation in Article 133 still holds good. For on looking, there we go. For on looking at 147,326 over 1 million, in the table, we find it is 1/10 plus 4 over 100th plus 7 over 1,000 plus 3 over 10,000 plus 2 over 100,000 plus 6 over 1 million. The next fraction is the same value, which is 147,326 over 10 million, which if we find by the table to be 1 over 100 plus 4 over 1,000 plus 7 over 10,000 plus 3 over 100,000 plus 2 over 1 million plus 6 over 10 million. In this, 1 is not divided by 10, but by 100. If therefore we put a point before the whole, the rule is not true. For the first figure on the left of the point has the denominator, which according to the rule the second ought to have. The second carry-which? No. That which? Oh, that which. Oh, that's the problem. That looks too much like a K. So if we're going to do it, it has to be that which. Let's check that which, because it could be that it just wraps around. that which is not in there, which we'd already checked before. Now, what is interesting is that we have done that is, and the S wraps around, so it could be that we need to do the same thing here. So, let's go ahead and change it. Like so. That which. Like so. That which the third ought to have, and so on. Now, in order to represent the same rule for this case, we must convert. Contrive. Is that contrive? Yes. We must contrive. We must contrive to make 1 the second figure of the right of the point instead of the first. This may be done by placing a cipher between it and the point. Thus, 0.0147326. Here, the rule holds good, for by that rule, this fraction is 0/10 plus 1/100 plus 4/1000 plus 7/10,000 plus 3/100,000 plus 2/1,000,000 plus 6/10,000, 10 million, which is the same as the preceding line. Since 0/1000 is 0 and need not be reckoned. Yes, good. Next, similarly, when there are 2 ciphers more in the denominator. Oh, I meant to do in the 2 ciphers more in the denominator. That was like denominator or something. In the denominator, there we go. Then there are figures in the numerator. The rule will be true if we place 2 ciphers between that point and the numerator. The rule therefore stands more. The rule therefore stands. Stated. The rule therefore stated more fully is this. And then we write this down. To reduce a decimal fraction to a whole number and more simple decimals alone if it do not contain, there we go, if it do not contain a whole number or does not contain a whole number, mark off by a point as many figures from the numerator as there are ciphers in the denominator. If the numerator have not places enough for this, write as many ciphers before it as it wants, places, and put the point before these ciphers. Then, if there be any figures before the point, they make the whole number which the fraction contains the first figure as it after the point with the denominator 10, the second with the denominator 100, and so on, or the fraction of which, or the fractions of which the fractions are composed. All right, that's it. And we move on to 135. Grab another sip of water. We have about 6 minutes left, so let's just do as much as we can, and we just keep on keeping on. Keep on keeping on. Wada-wap-bada-bada. It's nice. It's nice getting to the point where you're just a little faster. You feel a little less stupid. Okay. Decimal fractions are not usually written at full length, so let's go ahead and do the next paragraph. 135. Decimal fractions are not usually written at full length. It is more convenient to write the numerator only and to cut off from the numerator as many figures as there are ciphers in the denominator. As there are. That should become a phrase. As many ciphers are placed as there are ciphers in the denominator. As there are ciphers in the denominator. When that is possible by a point. Whoopsie, come on. When that is possible by a point. When there are more ciphers in the denominator, than figures in the numerator, as many ciphers are placed before the numerator. Or placed before the numerator, are placed before the numerator. As will supply the deficiency. As will supply the, oh, two new words, supply and deficiency. Yep, that's supply and deficiency. Let's check that one out. There we go. Oh, nice, okay. So it uses the diff format. There we go. Excellent. Let's try one more time. Deficiency. There we go. Good. Deficient. Wow. Hardly any time left. As many ciphers, and that's our time. Wow. Okay, all right. Well, I'm going to call it there because 135 is going to be a long one. So I'm going to leave it for there and going to go ahead and get some dinner. Oh. Yep. I'm going to go ahead and get some dinner now. And yeah, so that was pretty good. What did we get through? Was it 3 pages? 72. Page 72, we got through Article 134. Where did we start? Let me pull it back here. I want to see this. We started on 130, so we did four articles over the course of this study session. Very nice, very nice. Getting faster as we go. All right, so I'm going to go ahead and call it there. Thank you very much for watching. I hope you all are having a wonderful evening, and I will be back shortly. So, see you in a little bit. Bye-bye.